Okay. Welcome everyone to lesson six for this year. This is our YouTube channel for our class lesson recordings. And today we'll be doing physics and then astronomy and then ending off with a new topic, which is music.
All right, so since we've covered most of the topics in physics, today is just going to be more of like a recap. So, yeah, so we're just going to be reviewing some topics such as kinematics. And as you guys remember, kinematics is basically just, we have the initial velocity, the final velocity, the displacement, the acceleration, and the time, which are basically like the five important variables. And then we also have five important equations that go with the variables. And each equation misses one of the variables, which basically makes it useful. So we have the final velocity equals initial plus acceleration time, and then displacement equals initial velocity times time plus 1/2 at squared. And then b bf squared equals b0 squared plus 2a displacement x. That one doesn't have time in it. And then, yeah, and then displacement equals to vt equals 1/2 b initial plus b final times time. And then that one has no acceleration. And then displacement equals v final time minus 1/2 at squared. That one has no initial velocity. So yeah, when doing these problems, you can keep these equations in mind. Um, yeah. So here's just like a problem. It's pretty easy. A car that's initially traveling at 10 meters per second accelerates uniformly for 4 seconds at a rate of 2 meters per second squared. How far does the car travel? So I'll give you guys some time to do this problem, but basically you want to look at these equations and pick out one of these equations to use to solve this problem. And you also want to like be able to identify the variables. But yeah, I'll give you guys like a couple minutes to do it. And if you have the answer, you can put it in the chat or you can say it out loud, I guess. And yeah, I'll review the solution um in a bit if no one can get the answer. Okay, is anyone coming close to an answer or if you have an answer you can put it in the chat. Just a hint, um you probably want to use the second equation to do this problem because you're given the acceleration, the time, and the initial velocity. Yeah, and you want to solve for displacement or yeah. Okay, if no one has an answer, I'll just reveal the solution. So pretty much you just have to identify the variables and plug it in. So a car that's initially traveling at 10 meters per second, so that would mean that the initial velocity would be 10 meters per second. And it states that accelerates for 4 seconds, so you know that the time is 4 seconds, and then accelerates at a rate of 2 meters per second squared. So now you know that the acceleration is 2 meters per second squared. So knowing these three variables, you can see that the second equation would be appropriate to use. So displacement equals v initial, which is 10 times the time, which is 4 seconds, plus 1/2 a acceleration, which would be 2 times the time again, which would be 4 squared. So yeah, that would end up to be 56 meters, which would be the right answer. Okay, and then another topic that we covered before is forces. So obviously there's a lot of different forces. There's like the normal force, um, as you can see on the little picture there. There's also the gravitational force. There's a tension force. There's also spring forces, and there's also friction forces. But basically the most important equation when it comes to forces is probably the net force is equal to the mass times acceleration. So yeah, you guys definitely want to keep that in mind when doing any problem related to force. Um, so yeah, we'll get to a problem right now. It's not too difficult, I think. So how much tension must a rope have to lift a 50 Newton object with an acceleration of 10 meters per second squared? So, I mean, hint, you want to use F equals ma for this question. And yeah, gravity would be 10 meters per second squared in this. Yeah, so when you guys have an answer, you can put it in the chat. Just remember that F in this case would be net force, which basically means that all the forces. So if you draw a free body diagram, which I should have added here, but the tension force would be going upwards, obviously, right? And there would be like gravitational force going downwards. So the net force would be the tension force minus the gravitational force. So yeah, I'll give it a minute, and then I'll probably just reveal the solution if no one can get the answer. Okay, does anyone have an answer or coming close to one? Or else I'm just gonna reveal the answer. So pretty much, um, like I said, so the net force in this case would be the tension force minus the weight. And this part's a little bit tricky, but to calculate the mass, you want to divide it by 10. So 50 newtons over 10 would give you the actual mass, which would be 5 kilograms. So you do F equals ma, where the net force is tension minus weight, and you compare that equals ma. And as we just solved, mass is 5 kilograms, and then the acceleration is 10. So that would give us tension equals weight plus 50 as we solved, just moving the weight to the other side. And then as we can see, the weight would be 50 newtons. So 50 plus 50 would give 100 newtons. So yeah, that would be the tension force. And I think that's it.
All right, for astronomy, we're going to be talking about neutron stars. So basically, neutron stars are the collapsed core of a massive supergiant star. which are generally 10 to 15 times the mass of our sun. Neutron stars are the smallest and most dense class of cosmic object other than black holes. And they generally have a radius of about 6 miles with a mass about 1.1 to 2.16 times that of the sun. They're basically formed when any normal star that is at least 8 times the mass of our sun exhaust all their fuel, which then causes like the outer layers of the star to explode in a supernova, which would only leave like their core, and that remnant core would be the neutron star, unless it had a mass exceeding 3 times that of the sun, which then it would collapse into a black hole. The properties of neutron stars, so like their temperature, if they're newly formed, is around 100 billion to 1 trillion degrees Celsius. But within a few years, it falls to only about 1 million degrees. They're also incredibly dense. I think it said that like 1 sugar cube of the material on that makes up a neutron star weighs as much as a mountain on Earth. And the gravitational force of a neutron star is also very powerful. It's hundreds of billions times stronger than Earth. Like the escape velocity to like escape into orbit is like half the speed of light. Yep, that's about it.
Okay, so I'm gonna teach music, and today we're gonna learn about note reading. So the basics of music theory. So first, how is music written down? So we write music on a staff, and the staff has 5 lines, which is shown below. And each line or space represents the pitch of the note. And the notes are named after the first 7 letters of the alphabet, so A, B, C, D, E, F, G. And for a typical scale, you would start from C, and then when you get to G, you go back to A, and then A, B, C. So that would be all the notes in the scale. And then the distance from C to the next C is called 1 octave. Yeah. So other than those 7 notes, there are also 5 more notes in between. So if you ever seen a piano, there would be 7 white keys in 1 octave and 5 black keys. So the white keys would be C, D, E, F, G, A, B, C. And then the 5 notes in between would be like sharps and flats. For example, the black key in between C and D would be called C sharp or D flat because it's a little higher than C, but a little lower than D, but it's the same note. And then between D and E would be D sharp or E flat, and so on. But there aren't any black keys in between E and F. And there aren't black keys between B and C. So just remember that. And then another concept is clefs. So if you notice on the first slide, there was only the clef on the top. So the clef is basically that symbol at the beginning of the staff that looks like a squiggly symbol. So the one on the top is called a treble clef, and it represents higher pitches. And the one on the bottom is the bass clef, and it's for lower pitches. So even though all the notes are written on the same 5 lines, the staff, or no, not the staff, the clef would determine the pitches. So if you're using a treble clef, then the first note there would be a C, but if you're using a bass clef, the first note would be an E and it's much lower. And then the last note on the bass clef is one note lower than the first note on the treble clef. And then if you use both of these clefs together, it would be called a grand staff. And normally, like instruments like the piano would use the grand staff, and higher pitch instruments would use treble, and lower pitch instruments would use bass. Yeah, that's it.